Hello and Assalamualaikum everyone. My name is Izzaty Alia Miti Kamaruzzaman, student ID TH21035. So today my group and I will present our project, which is the ultrasonic radar. So the introduction. What is ultrasonic sensor? Ultrasonic sensor is a device that uses ultrasonic sound wave to determine the distance to an item. So what it use? The ultrasonic sensor are used in a variety of technical fields in automation, robotics, and instrumentation. No contact distance measurement is extremely valuable. So ultrasonic sensing is one of the most reliable ways to sense proximity and detect levels. So how does it work? So the ultrasonic sensor functions by emitting the sound wave that is above the human hearing range. The ultrasonic sensor, also known as a transducer, work in the same way that our radar system does. Electrical energy can be converted into acoustic wave and vice versa using an ultrasonic sensor. The acoustic wave signal is a high frequency ultrasonic wave that travel over 18 kilohertz. So, description made up of a simple ultrasonic sensor mount on a servo motor that rotates at a specific angle and speed. It connected to Arduino digital input-output pins as is the servo motor. So the employs a radio wave. This is an this is an object detection system that employs radio wave to assess whether there is an obstruction in a 180 degrees viewing angle. So, sensor detects on obstruction. The ultrasonic sensor will use radio waves to identify an item, and the servo motor will spin the ultrasonic sensor to 180 degrees. The process of application will display a red region where the impediment was identified. So, list of components that we use to run this project. The first one is Uno Arduino. The second one is ultrasonic sensor. Then a micro server, the breadboard, a male to male jumper, and male and female to male jumper. And then the problem statement of this project. So the speed of sound is variable in different medium, also depend on temperature of medium. Manual manipulation are required. So next, the object should be a good in reflecting surface. And then the object should be placed near the rotation of transmitter. Less reflection will take place if the angle are not wide. The size of object also important so that the wavelength of signal can detect the object. So the object that we use should not be too small. So in a medium size is okay. And then the signal get weakened as they propagate through the medium. Attenuation depends on the frequency of signals, putting a constraint on the range of the system.
Hello, my name is Natasha Ava, and my metric number is TH21036, and I'll be presenting now. From what you can see here, this is our flowchart for our ultrasonic radar, and the type of control structure that we're using for our project is called repetition, or in another word, looping. Now let's look into the component when we assemble the ultrasonic radar. First, we have the Arduino, wires, the motherboard, the micro servo, and the ultrasonic radar. This is how it looks like when we assemble the component, and over here is the second picture when we look to the side. Now let's look into schematic and simulation diagram for the ultrasonic radar project. As we can see here on our left, when the microserver turned the ultrasonic radar at an angle of 109 degrees, there is no object detected within the range of the ultrasonic radar. Meanwhile, on the right side, when the microserver turned the ultrasonic radar at an angle of 99 degrees, the radar can detect the object. Now let's look into the schematic diagram for the ultrasonic radar in Tinkercad. As you can see, we have the Arduino Uno itself, the motherboard, and the connecting wires, along with the micro servo and the ultrasonic radar connected through the motherboard and as well as the Arduino. Now let's look into the programming code for our ultrasonic radar. This is the first half of the programming code where we will define the trig and echo pin for our ultrasonic radar, and then we will write in the variable for the duration and distance, and then next we will put in the variable to store the micro servo's position, and then next we will go to the looping over here, the first loop where it will rotate the micro servo's motor from 1 to 180 degrees. Next, let's look into the second half of the programming code. As you can see down here, this is the second looping where it will repeat the previous line from 180 to 1 degree, where the micro servo will rotate the ultrasonic radar from 180 to 1 degrees. And the programming code down here is to calculate the distance measured by the ultrasonic radar.
Hi, Assalamualaikum. My name is Aishah Umairah binti Zuridi and my student ID is CH21014. For this slide, I will tell a little bit about the schematic for the Visual Studio for the ultrasonic radar. Here we can see the window form. In this window form, you can see there's a picture box here. We also have push button for the detect object. We also have another push button for the stop detect. We also have level 1 here. As we can see in this picture, this is the thing that will display in our screen once we run the coding. This is the coding for the Visual Studio. This is the first flow, the second floor, the third floor. Okay, I will tell a little bit about this. We use this coding in the window form applications. We also use the C# language for this coding. This is the schematic and simulation picture for the ultrasonic radar. This picture will display in our screen once we run the coding. Yes, now the conclusion. Okay, the conclusion, this project with the ultrasonic sensor can be custom-made. It can be fit in a car to avoid when reversing, to tell the level of water in a well or storage tanks. Also, to implement with the GSM for proper remoting monitoring. And the third one is use in a tunnel for train or vehicle tunnels to give signal. And then the objective of this project is to design and implement an ultrasonic distance measurement device. Improvement and suggestion. This project can be improved By the range can be considerably increased by using high-power device circuits. First, we expand the range of the tracking moving object. Second, we using the temperature compensation. It can be used over a wide temperature range. Third, we use to increase the number of the moving object that can be detected. That's all from me. Thank you.